Hello everybody. In this class, we will learn about automotive fuses and light bulbs. Oh, why doesn't my car's left front high beam come on? What fuse are you talking about? What kind of bulbs are in my car? I guess I will have to do some catching up. We will start by learning about automotive fuses. Let's get to know fuses in the following ways. First, function and structure. Second, the classification of common fuse. Third, symbols. Fourth, how to select. Fifth, how to check the fuse is good or bad. Sixth, replacement considerations. Seventh, mounting position on the car. First of all, the function and structure of fuses. The fuse is connected in series in the circuit, using the heat effect of the metal. When the current is too large, the fuse breaks and cuts off the protection circuit, providing overload protection. The so-called heat effect is based on Joule's law, that metal conductors give off heat when they are electrified fuses, connected in a dry circuit, to protect the entire parallel circuit. Individual fuses protect parallel circuits off. Each circuit. The fuse consists of three main parts. For the electrode part, there are usually two. It is an important part of the connection between the melt and the circuit. So it must be good electrical conductivity and should not produce significant mounting contact resistance, or it will heat up. The fusible part is usually a metallic fusible wire. It is the core of the fuse and works to cut off the current when it blows. For the bracket part, the fusant of the fuse chamber is generally slim and soft, so the bracket is to hold the fusant in place and to make the three parts into a steel hole. For easy installation, some of the fuses are also filled with quartz sand inside, which acts as an arc extinguisher. Common fuses include fusible tube type, which is the high voltage service switch on electric vehicles, as well as fork bolt fuses and insert fuses. This is a common graphical symbol for fuses, and the text symbol is denoted by FU. This is the Geely EV450, and its graphic symbol of fuse and circuit diagram. Fuses are classified into small, medium, and large loads. The important principle of fuse selection is that the rated current of the fuse is determined by the size of the rated current of the automotive circuit, and that is not possible to bypass the fuse or replace the fuse with the larger capacity fuse that has been designed by the manufacturer. Many automotive fuses are grouped together with the name and rated capacity of each fuse indicated and mounted into a fuse box. And on the cover of the fuse box, the name of each fuse and the rated capacity are indicated. We can use the information on the box cover to find the relevant parameters of the fuse. Automotive cartridge fuses are typically sized from 2A to 40A. Its amperage value will be marked on the top of the fuse. Internationally, different amperage values and different colors correspond. If a fuse is blonde, leaving the amperage value unrecognizable. We can also tell by its color. Internationally, 2A corresponds to gray, 3A corresponds to purple, and so on. So, I won't list them all. Similarly, amper-rated cartridge fuses are also available in medium, small, and miniature sizes. We can use the visual method to make a good or bad judgment on transparent fuses. Clearly, we can see that the middle fuse is partially blown. We also determine whether a fuse is good or bad by the resistance method. In the event of a power failure, the resistance value of the amp file to infinity, indicating that the fuse is bad, close to 0 ohms, suggesting that the fuse is normal, and a few tens of ohms there may be a false connection. One other method used is the voltage method, which has the advantage of being able to measure the whole vehicle without degenerizing it. First, use a multimeter to measure the upstream ground voltage of a fuse on the voltage setting, and then measure the downstream ground voltage of the fuse, since the fuse resistance is very small. The voltage difference between the two measurements should normally be small. On the sixth part, we are going to talk about the do's and don'ts of fuse replacement. Firstly, the rated current value should be correct, and the size should be chosen appropriately. Secondly, when there is no spare fuse for an emergency, it is possible to replace it with a fuse from another device that has no effect on the safety of the driving machine. It is necessary to follow the principle of small, no big to replace, but should not be long-term replaced by different brands. Different models of automotive fuses. The mounting locations are fairly similar, mainly in the front cabin fuse box and the interior fuse box. The interior fuse box is under the main driver's side. The second major problem is automotive bulbs. According to the principle of light emission, automotive light bulbs can be divided into incandescent bulbs, halogen bulbs, gas discharge lamps, and LED lights. Incandescent bulbs filled with protective gases, a low-pressure inert gas, namely argon, neon, nitrogen. Its luminous efficiency is low. For halogen lamps, the protective gases inside the bulb that prevent oxidation of the tungsten filament are bromide and iodide. It can make the tungsten filament in the lighting high-temperature evaporation. In the cooling process, through the reduction reaction so that the high level of evaporation of tungsten return to the tungsten filament, improve the service life of the bulb, and high luminous efficiency. Luminous capacity model marking with edge, such as H1, H2, H3, and so on. Gas discharge lamp is through the high voltage. Electrode excitation gas emits a glow, such as xenon lamps filled with xenon gas, mercury lamps filled with gaseous mercury, and the luminous efficiency is very high. LED, also known as light-emitting diode, is a semiconductor device capable of converting electrical energy into visible light. With high electro-optical conversion efficiency, LED lights are cold light sources and are unaffected by vibration. Now let's briefly compare the features of the four bulbs. Incandescent lamps are cheap, simple circuitry, and the more power they have, the shorter their lifespan. Tungsten halogen lamps have high luminous efficiency, high durability, small size and compact filament, Xenon lamps are expensive, triple the brightness output, several times the product life, and consume little electricity, but are not suitable for frequent alternation between high and low light. LED lights have long life, short startup time, solid structure, low current consumption, small size and high weight. Lastly, let's review what we've talked about today. First, the role and structure of the fuse. Second, how to choose the fuse. Third, automotive bulbs. When we are faced with a variety of choices, we must be able to grasp the principle of selection and comprehensively consider its cost-effectiveness and practicality. That's all for this lesson. Have you guys got it?